All right, so we're going to do now parallel AC circuits. So let's say I got a circuit like this. And I got 2K ohms here, 3K ohms here, and 4K ohms here. Okay. So again, everything has to have an angle on it. Resistors are still 0. Now, let's see. Inductors are still 90. Capacitors are still negative 90. Because I gave you the inductor and capacitor in ohms, which means I've already given you X of C and X of L. How did I find R total in a parallel circuit? Well, it was 1 over the reciprocal of everything, right? So in AC parallel, it's the same way. 1 over R1 plus 1 over L1 plus 1 over C1. I'm still going to do it the same way. So I still got to do the reciprocal, okay, of everything. Here's the difference. When I punch it in my calculator, 2K ohms at an angle of 0 plus 3K ohms at an angle of 90 plus 4K ohms at an angle of negative 90. I can't just put 2K ohms at an angle of 90 shift reciprocal or an angle of 0 shift reciprocal. I must put these all in parentheses and then put shift reciprocal. Because if I just hit shift reciprocal after I put 2K ohms at an angle of 90, it's only going to shift reciprocal my angle. And I do not want it to do that. I want it to shift reciprocal everything. And then you're going to get it equals, and then you're going to get an answer. Here, you're just going to hit shift reciprocal like we did in DC, and then you'll get your final answer. Okay, you don't have to worry about parentheses. Once you do these in parentheses, you hit equals, and then just hit shift reciprocal again, and it'll shift reciprocal, and you'll get your answer. So do that up in your calculator and tell me what you get for an answer for Z total. Put it in just like I wrote it on the board. Open your parentheses, put your value in, close your parentheses, shift reciprocal.
You can come up here.
And in these, unlike DC parallel, your Z total may not be smaller than the smallest component you have. Because of the angles, sometimes you may get one that's bigger than the smallest component. So you can't just look at it and say, oh yes, it's smaller, so I must have done it right. Because they won't always come out that way. A lot of it depends on how big of a values you have for each of your components will depend on whether or not it'll come out smaller. Does anybody get an answer?
Yeah.
What'd you get?
1.972 K ohms at an angle of 9.462.
Outstanding. So just remember, you find Z total just like you found R total. The only difference is you got to make sure you put everything in parentheses when you do it.
That's
So let's try another one. Just getting Z total right now. So let's try. Let's try that one. See what we get for Z total equals. And I'll give you guys a few minutes to figure it out.
70.
All right, did anybody get it?
I got a little bit different answer. I got 973.
Yeah, he got 973.
With an angle of 13.299.
973 what?
Ohms.
Ohms? So he
Okay.
says not, he got 973. Anybody get anything different?
I got 981.148 ohms with an angle of 11.143.
With an angle of 11.143.
Yes.
I
Anybody
got
get
927.504 ohms
504 ohms.
at an angle of 21.951.
951.
951.
Anybody get anything different? Did everybody get at least one of those three answers? And that is a 7, not a 2.
But for the top one, it's 973.185.
0.185.
Yes.
Oh shit! I know why my answer's wrong. I didn't see that.
0.185.
I did mine wrong. Oh, you know what?
That is the correct answer. 927.504
That's what I got.
at an angle of
Damn.
21.951.
Sorry.
So when you did it, make sure you put your angles on everything. Resistor, angle 0. Inductor, angle 90. Capacitor, angle negative 90. Inductor, angle 90. And then make sure when I put them in my calculator, I put everything in parentheses before I hit the shift reciprocal. So I want to put 1 K ohm, angle 0, in parentheses, then shift reciprocal, plus 2 K ohms, angle 90 in parentheses, shift
Oh, that's
reciprocal,
what I did.
plus 2.5 k ohms, angle negative 90, close my parentheses, shift reciprocal, plus 3.3 k ohms at an angle of 90 in parentheses, shift reciprocal equals, I get my answer, and then I just hit shift reciprocal, and it equals my answer.
For the second inductor, I plugged in 3K instead of 2K.
Ah, that'll do it. That will
So-
definitely make you off.
Mhm.
Make sure you can read from the problem from here to putting it in your calculator. Okay. And see, the good thing on the test is if you put that, if you write it out like this, then I know you were doing it right, you know. And then I can say, okay, you punched something in the calculator wrong.
I know what I did wrong. I did it right. The math is right. I just totally missed one whole value. I
Oh,
did it
Jesus.
with 3 components.
Ah, you missed the fourth component.
I'm gonna go put my glasses on.
So, okay, so fairly simple, right? Not hard. Just got to remember to put everything in parentheses and all that good stuff. So now let's actually figure out a problem. So let's do one. So let's say I got something like this. And I want to get that's what I want to get. Oh, and I want to get my I total. Forgot I total. How am I going to go about getting these values? Well, one, I'm going to go in and I'm going to put angles on everything. I know resistors are 0. I know capacitors are negative 90. And I know inductors are 90. Now I'm going to get my Z total. How am I going to get it? The same way I would in a parallel circuit, DC, just
Add them up.
everything I'm going to, no, I do not just add them up. I have to do the,
We just did.
1 over the reciprocal. Okay, we just add them up in a series circuit. Here I have to do 1 over 1K at an angle 0 plus 1 over 4K at an angle 0 plus 1 over 2K at an angle 0. So I'm going to punch them in my calculator, doing the shift reciprocal, ensuring that I put them all in parentheses first. Because if not, I'm just going to shift reciprocal my angle, and I don't want to do that. So if I punch all those in my calculator, 1K ohm, angle 0 in parentheses, shift reciprocal, 4K ohm at an angle negative 90, in parentheses, shift reciprocal, 2K ohm at an angle 90, in parentheses, shift reciprocal, equals shift reciprocal, I should get 970.143 ohms at an angle of 14.036. Okay. I'm giving this one as an example, and if I can get this video posted, you guys can go back and punch everything in and make sure you're getting the correct answers. Now I'm going to get my I total, because that's the next conceivable thing to get, using my Ohm's law. 20 volts at an angle of 15 divided by my Z total will give me my I total. When I punch that in, I should get 20.616 milliamps at an angle of 0.964. Okay. And all I did for that was I took E total divided by my Z total, and I got I total. How am I going to get the current through each one of my components? Well, what do I know is special about a parallel circuit?
Voltage stays the
Voltage
same.
is constant.
Voltage stays the same. So my voltage drop here is 20 volts at an angle of 15. My voltage drop here is 20 volts at an angle of 15. And my voltage drop here is 20 volts at an angle of 15. Now I can simply use Ohm's law. Voltage divided by my impedance gives me my current. Voltage divided by my impedance gives me my current. Voltage divided by my impedance gives me my current. So if I do this one, I get 20 milliamps at an angle of 15. This one, I get 5 milliamps at an angle of 105. And when I do this one, I get 10 milliamps at an angle of negative 75. What am I going to do then? I'm going to add up IR1, IC1, and IL1, and it should equal my I total, just like I did in a DC parallel circuit. And when I added those up, when I did it, I got 20.6155 milliamps at an angle of 0.9638. So that looks like it's pretty comparative. So it checks. So I did it correctly. Everybody see how we're doing it? We're doing it the same way we did DC. It's just now everything has an angle on it. Voltage still stays constant in a parallel circuit. I'm still going to find my Z total, my I total. When I get all the currents through all my components and I add them up, they must equal my I total. Just like we did when we did DC and we found all the currents through all the resistors. We added them up and they had to equal I total. Same thing here. Anybody got any questions about parallel circuits?
I actually got that part right.
Good, because everybody's good